Find the integral of sine of theta over cosine cubed theta d theta. All right, so we do see we're dealing with trig functions here, right? And well, I mean, I know that's, sine over cosine is tangent, right? Which leaves us with a cosine squared in the denominator. But there's really nothing we can do with that, okay? Now, we do see that, well, there's a sine in the numerator, there's a cosine cubed in the denominator, okay? So we can do a couple things, right? We can let u equal sine of theta, but then du would be cosine of theta, but that's in the denominator, right? So that won't be good. So let's let u equal cosine of theta, okay? So if you let u equal cosine of theta, then the derivative, we know, is negative sine of theta d theta. And that's the key because we see that sine theta up here in the numerator, right? Let's think about that, right? Here is our u. Well, in this case, it's actually going to be u cubed, right? But here is our du, right? The sine theta with that extra negative in front. So what does this become then? This becomes negative, okay? 1 over u cubed du. All right, so this one gets a little bit tricky just because of the trig functions, right? But the key point is to understand that once we use a substitution, right, we should see that derivative pop up, and we should be able to replace everything inside the original integral, okay? Now for this, I mean, we can just use a power rule for this, right? I mean, we can rewrite this as u to the negative third power. So using the power rule, right, what happens in this case? This becomes negative u to the negative second power all over negative 2 plus c. Okay? And all these negatives cancel out. This will bring out the 1/2, I guess. And u to the negative second power plus c. Of course, the last step is to make sure you put that u back in there, right? The cosine of theta. So we'll do 1 over 2 times cosine of theta squared plus c. And this is going to be our final answer here.